You have these systems that monitors every individuals and the whole groups of animals. And then from that, you look at patterns of what's going on over time, let's say over weeks, on days. And then whenever the patterns of something wrong start to emerge, these kind of system can alert farmers saying, go check on this group of pens or this group of animals. I predict something wrong will happen in 3 days, maybe with this particular pig or within this pen. So this is what we call early warning system. So before a disease start or an outbreak start and can have more negative impact, this system can give the heads up and say, go check now, maybe this is the best part.
Welcome to our latest edition of Swine podcast. I'm 𝗟𝗶𝘀𝗁𝘀𝗁, your host. And today we have a special guest, Dr. Alameer. Dr. Alameer, welcome to our podcast today.
Hi, Jerry. Thanks very much. Thank you. Yeah, thanks for having me.
Very good. I'd like to maybe just introduce to our viewers and give us a little bio of yourself.
Hi, I'm Ali Alameer. I am a lecturer in artificial intelligence. I currently work at the University of Salford in Greater Manchester in the UK. I have had a PhD in AI, in artificial intelligence, and particularly in machine vision. And I've done that between 2014 and 2018 at Newcastle University, also in the UK, the United Kingdom. And after that, I did several postdoc positions, and all of them were specialized in using whatever I developed in my PhD, which was mainly a machine vision system that makes sense of the world and use that knowledge into the pig farming industry. And that's how I started my journey within this exciting.
Very good. Very interesting. And you've done a lot of work in artificial intelligence and machine vision. And so that's kind of where I'd like to focus today and how we can, utilize that in agriculture going forward and improve, animal welfare, different things with agriculture. But maybe for our viewers, just kind of define a little bit, machine vision and artificial intelligence. What are those?
So artificial intelligence is a broad umbrella for many of things. The easiest way to define it is to make a computer, in lay terms, do simple actions that can simulate intelligence, that can show intelligence. This could be opening a door automatically when you approach a door. This, as simple as that, that's count for artificial intelligence. But then within that, there's a field, another umbrella called machine learning. And that is an exciting field in which the machine learns from data to become better at doing tasks. And this can be anything from learning to diagnose people who may have diabetes to many other kind of applications. So it gets data and it learns from the data and then makes prediction based on this data. And then within that, we have another field that emerged within machine learning. It's called deep learning. So this is when things started to become more exciting. And this is actually started to become more popular within the time I started my PhD in the field. And that is when you have a machine learning system or neural network that is a shallow neural network that will have many, many layers. And by many layers, I don't want to confuse listeners, is imagine them as numbers, a lot of numbers that just get multiplied with another numbers, which is the input data. Because in the end, when we speak artificial intelligence, we speak in numbers. Basically, everything, whether it's text that we put, whether it's images that you see, everything is numbers in the end. So once these numbers are put to the computers, we look for patterns within them. We look for stuff to produce things. So going back to the definition of deep learning, which will be covered a lot, I think, in today's podcast, is the deep learning, which involves many layers, which are millions of numbers, that does magic when it gets multiplied or convolved or with simple, in my opinion, very simple mathematical kind of expressions. But this multiplies many, many times and learn through many iterations, and it becomes very good at doing pretty much everything.
And you mentioned artificial intelligence. I think a lot of people have heard that word, but what spaces are we seeing, artificial intelligence today, where you're seeing that grow in? What are some of the spaces? Manufacturing, what have you? Maybe talk a little minute, about what are some of the areas where you're seeing this really grow?
Pretty much everywhere. The main one is surveillance, which is going to be correlating with what I'm going to talk about: animals, health, prediction of diseases, analyzing data. You have X-ray images, and then AI can look at anomalies, patterns that can tell you this X-ray contains something maybe malicious, maybe it's okay, go investigate that. Pretty much everything. Face recognition, we all use iPhones. We unlock our phones with this kind of technologies, detections of kind of pedestrians in the streets, car detections, a lot of applications. There are a lot of applications of AI, and then I'm talking now only about machine vision, which is a field of AI. There is also natural language processing. That's another field of AI which involves text. So that's when you have, for example, ChatGPT now, which everybody talks about. So everything that involves text. So again, when I talked about deep learning earlier, deep learning deals with numbers in the end, and text will be converted to the computers through numbers. And these numbers, this text will have an embedding in the embedding space, which represent the best numbers that represent every word in a dictionary, let's say. And when these numbers are embedded in a good way, then you have very good representation for these numbers. You have semantic relationship between words, where you see computer by itself understand genders, understand capitals of the world, understand all these kind of complex hidden patterns within the text itself. So then we go into NLP application, and that is like chatbot, that is like sentiment analysis. So somebody could analyze what we're talking about today and get sentiments of what we're talking about, or topics, or whatever, using just the text that we're speaking about. And there are many other fields, and I could talk about them until tomorrow.
We could take the whole podcast talk about that. Well, obviously we're interested in agriculture. So how did you get interested, taking this technology, taking it and applied it in agriculture? How did you get started with that?
It's a very, very exciting journey because, as I mentioned earlier, I did my PhD from 2014 to 2018, developing a machine vision model, which is part of AI, that can simulate the human brain, the first 100 millisecond of the human brain kind of capabilities of making sense of objects, scenes, etc. So developing this model, I learned a lot of about machine vision, image processing, all these kind of techniques, and I had a model that to some extent compete with the state-of-the-art back then deep learning algorithms. So I've created a bunch of kind of models that does very well in different tasks in terms of recognizing pretty much every object that you see or scenes. Or so you have a camera, and there's a sophisticated model behind the camera. And this camera can literally observe the environment and make sense of everything that it sees, whatever you want it to actually, whatever you're interested in. So after finishing this PhD, which was general in visual and pixels and machine vision and object detection and classifications, I was looking for a position that takes this kind of knowledge, this kind of model, into a real world kind of implementation, to a place where I can put this kind of knowledge and do stuff that actually make an impact in this. And that's when, at the same university, I applied for a position, a postdoctoral position, to do this kind of research within the agriculture school back then, and take this kind of model and do this interesting stuff about pigs in particular. And then after that, I got another position at Queen's University, Belfast, also within the United Kingdom, which is also to do kind of similar research and extract more sophisticated pig behaviors to do with tail biting, etc.
FeedFlow is changing the way the swine industry sees feed. As the world's only on-pipe feed sensor, FeedFlow tells you exactly how much feed is being delivered to your animals, so you can be sure that every pig in your barn is well fed and growing. With industry-leading precision and up-to-the-minute real-time data and alerts, FeedFlow is a simple and affordable way to improve production outcomes across your organization. Feed is too expensive to ignore. Try FeedFlow today.
So the area of agriculture you think is really where you kind of landed first is pig behaviors. And that's an interesting, because I think we've got a lot of gaps, and that's an issue. We don't really understand the behaviors per se, because we walk in a barn, we're there maybe an hour. We watch what's going on in those, and we try to assess what happened in that 1 hour and predict what's going on, and so it's very tough. So I think that this is an opportunity very that we can understand and learn more. So how does that work when you with those looking at behaviors? What are some of the things it's been able to learn?
Yeah, what you mentioned is very interesting, because this is actually the main motivation of this type of research in this industry, is that it's not practical to go into a barn or a pen full of pigs, a large number of pigs, and you have many pens usually, and then just keep looking at them day and night to then get understanding about what's going on in terms of health and welfare kind of compromises. So that's the main idea. You have an amazing tools that exist right now that can do exactly that, and it's been used almost everywhere in surveillance system in general, whether in metro or airports or whatever kind of surveillance that exists right now. So similar kind of system that already exists can be applied. You have an inexpensive camera that is at the ceiling of the pen and does exactly that, but does it, I would say, 1,000 times better, because it looks at every animal every second of every day for weeks and months without getting tired. It looks at them at night, in the morning, in the afternoon, and then continuously get behaviors. So you end up with a large profile for each animal, which you can get data that you never thought even existing before. So that's the main motivation of these tools.
That's a good point. Group settings, it's very hard to look at each individual animal simultaneously, as you said, and understand what's happening. The dynamics change, as we got animals in group settings, and I think to your point, that's going into, we're going into more open pen settings where animals are mixed, maybe more so than they were, and so it's really crucial. And it's hard to understand exactly what's going on. It seems like, animal welfare has been more of an art, trying to predict what's the best. And now we're going to have some real data to really, some science behind the recommendations, I think is going to be important. So Dr. Alameer, how do you predict this is going to be used and applied in systems to help caretakers as far as with husbandry? What are some of the applications you see?
That's to do with monitoring in particular. That's what I did myself. So continuous monitoring of behaviors in a micro level, in a way that has not been done before, where you look at animals every single second of the day, what they're doing. And I think this is the way I see it. And also, the main one is predicting problems very much earlier than the current way it is done. So you have early warning systems. You have these systems that monitors every individuals and the whole groups of animals. And then from that, you look at patterns of what's going on over time, let's say over weeks and days. And then whenever the patterns of something wrong start to emerge, these kind of system can alert farmers saying go check on this group of pens or this group of animals. I predict something wrong will happen in 3 days, maybe with this particular pig or within this pen. So this is what we call early warning system. So before a disease start or an outbreak start and can have more negative impact, this system can give the heads up and say, go check now. Maybe this is the best time to go.
Yeah, I think that's a good point, because a lot of times we're behind the we're after the fact. We notice that an animal's gotten sick, and we're trying to attenuate that sickness or illness, or maybe something else. They're lame. She's starting to limp, and if we know ahead of time, maybe we can apply an intervention and have a more positive outcome. So I think that's a really good point, where I think I see this being a really good application of enhancing, the caretaker. Not necessarily, we talked about behavior, but just, the animal welfare of making that intervention with that animal and preventing injury or sickness. It's kind of hard when you've already, the cow's already got out of the gate. It's kind of hard to shut it then. But if we can get ahead of the curve, maybe we can we can figure out what are some of the causes. That's where I think we shake our head. We got multiple causes of things, and we really don't know. We don't have data to really, suggest what can we do earlier. So what do you think? This seems exciting. What do you think are some of the barriers that we're facing today, and why we're starting to see it in other fields? Why haven't we seen it in agriculture?
My own opinion is the lack of faith of the kind of impact that these tools can make. So the moment that you have, let's say, or business owners believe that, this tool will make a short-term or long-term could be impact to my business, that's when you see more kind of investment and more belief in how powerful these tools are. It is surprising to me that the pace in this particular field is in a way lagging behind. I work in many programs across many kind of different parts of AI, and I can see that still the agriculture sector is lagging a bit behind with utilizations of these tools and what impact it can make for this industry.
Yeah, I have to agree. It seems like its age is part of it. It seems like the average farmer is probably 60s or late 50s, and not necessarily the generation that grew up with technology. And so I think there's a skepticism, and then they think it's too expensive. But sometimes it's just farmers just want to do things, they're really resistant to change. I think as a whole, farmers are very resistant to change, and so the age and then just the kind of personality of farmers, I think that's a good point. That we need some more younger. It seems like younger generation to get involved, and I think that's going to happen maybe eventually as some of these farmers pass on their farms to younger, and our age gets younger. Maybe some of those younger people are going to be more open.
The sentiment of using AI, I think it doesn't have a very positive sentiment within the general public in general. It's always, especially with animals, people who are more specialized in the field can articulate this better than me, but always prefer to have this human touch to the animals. And always there's the sentiment that AI will remove this kind of human touch from the animal, and it will be only silicon versus animals, and this kind of dystopian vision of how things will work. But that's where almost every industry is heading, and this conversation is needed, and needed by the right people, not by actually people like me. We are interested in numbers and pixels, and we can offer a lot of kind of exciting algorithms that does stuff that the farmers themselves need. So I'll give you an example. For example, for stuff from our side, every piece of research I've done in my career is done not by me. I don't have any interest to do these kind of piece of research. But animal behavior scientists come to me and say, we have this problem. We want to see, for example, how this group of animals do feeding or do drinking. Or we want to automate this. I remember the first time I started my first postdoctoral position, the PI back then, his name is 𝗟𝗶𝘀𝗃𝗃. He's one of the main kind of figures in the industry or in the field of animal welfare. He listed to me behaviors that he's interested to get data of. So he listed behaviors and he listed them with importance. He said, I want this behavior, that behavior, this behavior. So this conversation, and then people like me basically, especially now with how AI is developing exponentially, take everything you want to quantify is possible. Literally everything. If you want to see any kind of behavior in pigs, that's possible to make, to model and to quantify and to then analyze, to use for early predictor for anything, health, welfare problems, anything. So this is how it works. So people from that industry come to you with a problem, and they should have already talked about what implications, what that problem can solve, what implications that it brings. And then people like me will do it in the end, because everything is possible from a machine vision perspective. The way we look at any problem, we look at the image as numbers. In the end, every image is numbers, and this numbers is very rich with patterns, with interesting stuff, and we can do pretty much everything with these numbers.
Meet AccuFast, your trusted partner in raising efficient, healthy, and sustainable pork. We're not just about genetics, we're about tailored solutions that set you on your path to success, no matter how you define it. At AccuFast, we channel our investments into 3 crucial pillars: our genetic offering, proprietary technology platform, and leading commercial measurement system, ensuring tangible results for our partners. Visit our website at AccuFastSwine.com or reach out to an AccuFast customer success rep to discuss how we can help you create the future you've been working towards. AccuFast, the best way to predict the future is to create it.
You know, that's an interesting point you're talking about, that, you know, there needs to be a more collaboration across disciplines, you know, and bring in expertise. But I think as farmers, you know, we have a understanding of what we understand, and maybe we don't even understand, you know, that there is a way of solving this problem, because we got to bring in people that are experts. So that's kind of how you worked, you know, through developing these systems, is moving across, you know, engineers, data scientists, and then actually get, like I said, get to the farmers, the people in agriculture that have the problems. So that's very interesting. So that's how that's developed, helped you develop some of these systems.
All of them, all of the systems that I developed in the past, it started like this. Whether like the PI apply for funding, the funding could be to, for example, come up with algorithms that early predict tail-biting outbreaks in pigs, which is a problem that have a lot of, So we devised a system, we developed a system. Actually, I've done it, and I'm very proud of this piece of work. I think it needs somebody to follow up with it, because I think it has great potentials, although it didn't get as far with that particular kind of case study that we took. But I developed an algorithm that measures every contact that happens between every pig's tail, which is the rear, we defined it back then, or that's how we annotated it back then, and head. So in a way, we continuously quantified every contact that happens between every pig's head and pig's tail. And whenever we see this kind of patterns of these contacts increase or decrease, or whatever patterns it will have, we were hoping to predict tail-biting outbreaks days before it actually happens. So the way it works from our side is that, or in that case, we first developed the algorithm using data that was captured in Belfast, actually. And then we go into an experiment or trial, or we create the trial, or in that case, we took the trial from Denmark back then, from our university. And in that trial, they already have tail biting outbreaks and they have tail biting incidents and all this. So we look at historical data. So in a way, we implement the algorithm in a way that we know what's going to happen, but we want to see if the algorithm can pick up what's going to happen before it happens. So that's how we do research in these kind of field.
Yeah, I think that's as you mentioned tail biting. That's everybody's got that problem, from at some point or time. So that's something we just keep scratching our heads and trying to figure out. How do we do something after it's already started and it's almost impossible. So that's a perfect example. I think where we're going with this, we're going to be able to maybe predict and intervene with animals and have better outcomes for sure. So, but talking about artificial intelligence and we're thinking about how could that be even used? We see in the integrators, especially poultry integrators and processing plants, how they've used robotics. How do you see that maybe working on a farm, being able to do tasks that generally a person does? Do you see that developing?
With pigs, I have two experiences here. So the first thing, I'll give you my personal views about using AI in this industry. My personal views was always, that's why I was excited about this field, is always using non-invasive machine vision technology to replace whatever was invasive before then. So I'll give you an example. So in the pieces of research I've made, we were trying to replace the commonly used RFIDs to track animals. So you have sensors that is fitted on animals, and that has, of course, kind of welfare compromise or it's labor intensive. So you replace this with a fully non-invasive technology, a camera that is on the ceiling of the pen, touches no animal, and does the job. Regarding robotics, I've seen how robotics works. I've been to France to 𝗵𝗃 in France, one of the state-of-the-art commercial farms, commercial research farm, I think, and they have this automata in which it calculates how much each animal is feeding, and in a way to restrict the whole kind of scene is restricted. I'm not the best person to give you an overview about how it should be done, but I'm the kind of people who prefer to leave animals as kind of simple as they were thousands of years ago, and just let them do whatever they want to do, and just maybe use these technologies that are fully non-invasive, and get things that helps the animals in the end. That, for example, if the animals is displaying anomalies or displaying a kind of non-healthy behavior, this kind of camera and whatever algorithm behind the camera can tell you, this animal is actually, you have an animal that needs maybe checking, something like that.
Yeah, I think it's a good balance there between, as you say, these animals are exerting behaviors or want to exert behaviors that they did thousands of years ago. And as much as we try to change that environment, that's going to impact those behaviors. So maybe this is an opportunity we can go in and learn something and be able to, intervene and make that welfare better, make that animal productive. And it's going to be positive for everyone, for humans interacting with those animals, for the animals, for productivity. An animal that's more calm, that's more comfortable, is going to be more productive. So it's a win-win for everyone.
It's time for our famous three. A worldwide leader in animal nutrition, 𝗟𝗃𝗀𝗃's portfolio of products includes methionine, the full range of vitamins, enzymes, organic selenium, probiotics, mycotoxin management strategies, and palatability products. With such a diverse offering, 𝗟𝗃𝗀𝗃 supports its customers with a broad range of expertise, tools, and services to help them maintain a competitive advantage. 𝗟𝗃𝗀𝗃, fueling predictable profits. To learn more, visit 𝗟𝗃𝗀𝗃 at www.𝗟𝗃𝗀𝗃.com.
Dr. Alameer, we always ask the last three questions. First question, what is your favorite resource?
My favorite resource is actually my students. Before I just joined here, I was having a meeting with my students that I supervise. And it's so rewarding to see, like, I give them a kind of ideas about machine vision stuff or AI stuff or algorithms. And it's so rewarding to see what they take it to. And then I learn a lot from what they're doing. So I just show them how a technology or how a method or equation actually works. And they go do tons of work on top of it. They come back to me with something I never thought existed. So currently, I say I'm very lucky to supervise a lot of very, very brilliant students, and they are currently my resource in the field of artificial intelligence. I also supervise a PhD student who's doing actually a precision pig farming piece of work on predicting aggression in pigs. So that is also very interesting, and this student is using state-of-the-art machine vision algorithm that exists right now to predict aggression in pigs.
Well, that's, I've had other guests that said the same thing, or a couple. So I totally agree. It's just, it's the interaction we have with their students, and obviously they're young minds, and they spur us every day and encourage us, and we have faith. And I'm glad you got that student with precision farming, because I think that's, as we said, aggression is really an issue today with a lot of where we're mixing pigs that we've never mixed before, and genetically animals are becoming more or less docile, I think, in general. So more we can learn for sure. But very good answer there. Now, if you had think back to your career, who was maybe your most influential person in your career?
That's a very interesting question. The most influential person I would say is Dr. Hanan. I did my master degree in Baghdad, Iraq, before I came to the UK. And she taught me during my BSc and MSc. She was the first gate for me to delve deep into the artificial intelligence world. So she did very good job at teaching me actually mathematically and all these kind of to a very deep level. And now I get a very robust kind of understanding of this algorithm because I was built on a very good basics. She was very good with math and with all this kind of stuff that now students don't like to learn in a way. So she was the most influential actually person until today, and I kept going on that field until now.
Very good. It's always it always seems that we always have somebody that spurs our passion, I think, in fields, and totally agree. So lastly, if you look at what are the characteristics or traits that you find with people that are successful in your field?
Perseverance is the big one. I noticed I supervise brilliant students, PhDs and postdocs as well. And I noticed the one who go very far in life, not even my students, other colleagues and friends, are the ones who persevere. Like you get an algorithm, let's say, within the precision pig farming, let's say on aggression prediction. The problems with the field of artificial intelligence is that you have to persevere because you try a million times until you get to a very good product. You have very clever people. I know they're very smart. I know people who are very smart, but they don't have this kind of perseverance. And they give up. They build amazing work, but then they don't reach the final line. And usually the ones who persevere and get there are the ones. This is the trait that I believe it makes a difference in life in general.
Totally agree. It's that person that gets knocked down, that gets up, and like you said, you're going to fail more times than you're going to be successful, and just being able to deal with that and to keep going when sometimes maybe you don't have a lot of successes in the eyes. But I think in any field, like you said, sometimes when we find out something doesn't work, then that's just as important as finding out something does work, because then that takes away that pathway that we don't even have to worry about going down that pathway. So I think there's, I guess it's the glass is half full and not half empty. Kind of, I think applies to whatever you're doing. Is your point? It doesn't matter what you're doing. It's actually well, very good. I really appreciate your time here today, Dr. Alameer, and I really appreciate your work, your contribution. I think it's, as you say, I think it's a future of agriculture as we get technology and we'll be able to learn more and be able to understand what's going on more so, and we'll be able to find some real-time solutions to our problems. So very good. I appreciate your work and appreciate you coming on our podcast today.
Thank you very much. Thank you for having me.